types of single phase transformers.
After the class, please check if R18 COs are sent for us first year.
So in our syllabus, there are two types of transformers. So these are types of single phase transformers. Based on the constructional details of the transformer, we are classifying these transformers into two types. See, there are so many other types or classification of the transformer is there based on the construction and based on the number of turns, based on the application. So different types of transformers are there. But here I'm considering based on construction, the transformers are divided into two types. Am I audible to you clearly?
Yes, ma'am.
Yes, ma'am.
Okay. First one is core type transformer and second one is shell type transformer. These two are classified based on constructional details of the transformer. So let us see one by one. The first one, core type transformer. See, differences between core type transformer and shell type transformer, it is a very, very important question as exam point of view. What are the differences? What is a core type transformer and what is shell type transformer? I told you the two main parts in a transformer are nothing but core and windings. The remaining parts are also important, but we are considering only core and windings here. The core and winding. So this core type consists of, again, those core and winding. Those two parts will be there in core type also. In any type of transformer, those two parts are there, core and winding. So how those two are connected in core type and how those two are connected in shell type. Suppose if it is a core type transformer, core is covered by the winding. That means inner part is the core, and on the core winding will be covered like this. Core is covered by winding. In core type transformer, or winding surrounds the core, and it consists of, how many limbs are there for this core type transformer? It has, how many limbs here? Two limbs. So it has two limbs and two yokes. Vertical part is nothing but limb and horizontal part is nothing but yoke. So this core type transformer consists of two limbs and two yokes. So where these windings are placed? On yoke or limb? Where are these windings? Windings on
Lim-
limbs. Windings are placed on the limbs. So core type transformer means these are the points regarding this core type transformer. So it consists of two limbs and two yokes. Core consists of two limbs and two yokes. And in this, the winding surrounds the core. That means the outer part is the winding and inner part is the core. So on the core, on limbs, these windings will be placed. Both primary and secondary windings are placed on the limbs. So this is yoke and this one is, this is limb. Vertical part is limb. This is about core type transformer and application where we use this core type transformer. Core type transformers are used in case of high voltage applications. So if the transformer is carrying high voltages, so at that places the type of transformer used is core type transformer. Next, coming to the shell type transformer. Again in this also core and windings, how those two are connected. So in shell type transformer, just opposite to the core type. In core, winding surrounds the core, right? Now in shell type, core surrounds the winding, and this shell type consists of three limbs and two yokes. It has three limbs and two yokes. So then how it look like? See here, three limbs means, limb means vertical part of the core. This is one limb, and this is one limb, and this is one limb. So it consists of three limbs. And how many yolks are there? This is one horizontal part and this is another horizontal part. So it consists of two yolks, so three limbs and two yolks. And in core type, let us see the flux. Whatever the flux produced in the primary, the flux will links, the same amount of flux will links with the secondary also. So due to the current in the primary winding, flux will be produced, and that flux not only links with the primary, it will also links with the secondary winding. But now in case of a shell type transformer, sorry, both primary and secondary windings are placed on the central limb only in case of shell type transformer. But in case of core type transformer, primary winding is placed on one limb and secondary winding is placed on another limb. But in case of shell type transformer, both the primary winding and secondary winding both are placed on the central limb, that is in the middle limb. It consists of three limbs, right? So in the central limb, both the primary and secondary windings are placed. And now to the primary winding we will give the AC voltage, then current will circulate in it, and due to that current flux will be produced. Now that flux, let us assume that is phi. So at this point that flux will be divided and it has two parts. So half of the flux will flow here and half of the flux will flow here. So each limb carries what is the flux? Half of the main flux. Here the two limbs are carrying total flux phi in case of core type. But in case of shell type transformer, if you observe here, the flux produced in the central limb is divided into two halves, and one half is flowing in one limb and other half is flowing in the other limb. That means each limb is carrying half of the main flux. You can write that point also. Outer limbs carries half of the main flux. So what is that flux value? 5 by 2. And central limb carries total flux. Central limb carries a flux 5. But in case of core type, both the limbs carrying equal amount of flux. That is the main flux 5. Both the limbs will carry same amount of flux. You can write that point also. So these points are used while writing the differences between the core type and shell type transformer. Both the limbs will carry same amount of flux. See, if you have any doubt, you can ask me. Here, where the winding is placed in shell type transformer?
On the central.
On the central limb. So windings are placed on the central limb. And if you observe the figure, winding surround the core or core surrounds the winding here. In case of core type, core is covered by winding. That means outer part is winding and inner part is core. That means core is surrounded by the winding. Here,
Winding is surrounded by the core.
yes, winding is surrounded by the core. It means outer part is the core. So that's why windings are surrounded by core. And this shell type transformer application is, these are used in case of low voltage applications. core type transformers are used for high voltage applications and shell type transformers are used for low voltage applications. See, in our labs, you are doing experiment, load test on single phase transformer, open circuit test, short circuit test. So those you performed. There you used a transformer, right, to perform the test. So that transformer, which type of transformer it is? That is a shell type transformer. So for the practical testing purpose, whatever the transformers you are using, those are shell type transformers. So those are low voltage transformers actually. So for low voltage applications, whatever the transformer we are using, that is called shell type transformer. So these are the differences as well as constructional details of core type and shell type transformer. Then core type transformer, first write how many limbs and yokes are there in the core type and shell type. Next, either winding is surrounded the core is surrounded the winding. So that difference you have to write between the core type and shell type. In case of core, winding surrounds the core. Or core is covered by winding. And in case of core type, windings are placed on the limbs. And here, both the windings, primary and secondary windings, are placed on the central limb only. And here, the outer limbs are carrying half of the main flux. But in case of core type transformer, both the limbs will carry same amount of flux. Same as the current, how the current is divided at a junction point, in the same way the flux will also divide. So this is the junction point, right? So at this junction point, whatever the flux is coming here, that will be divided into two halves. So half of the flux will go through this limb and the remaining half will go through this limb. So these are the differences between core type and shell type transformer.